All right, class, today we are going to review a little bit about kinetic and potential energies, specifically gravitational potential energy. And we're also going to throw in a little bit of work, how it compares to kinetic energy. So we got a 6-part problem, or 7-part problem. We will go through part at a time and sort of talk about it. It's not too bad. It looks like there's more than there is. But first of all, we have a 3-kilogram puppy. It's dropped from someone's lap. It starts at rest, falls, gaining speed until it lands safely on the floor at 2 meters per second. So we know final velocity, we know initial velocity is 0, and it lands on the floor. So we don't know how far it went, we don't know how long it took, anything like that, but first the one thing we want to find out is kinetic energy before the drop. Well, on this page right here, we'll just go ahead and do it. So we know that kinetic energy is equal to 1/2 mass times velocity squared. Well, in this case, before the drop, it's not moving, so we know our velocity is 0. So 1/2 mass times 0 squared, doesn't matter what our mass is in this case, even though it is 3 kilograms. That's going to give us a kinetic energy of 0 joules, which makes sense. It can't have a kinetic energy if it's not moving. All right, so we're going in part 2. What's kinetic energy before the landing? Well, right before the landing, we'll say it's going 2 meters per second. So there's our velocity. So we use the same equation. Kinetic energy is 1/2 mass velocity squared. And we just plug the numbers in. We get 1/2 of the mass, which is 3 kilograms, times our velocity of 2 meters per second, quantity squared, gives us, well, 2 times 2 is 4, divided by 2 is 2, times 3 gives us 6 joules. So it's got a kinetic energy of 6 joules right when it lands. So change in kinetic energy of the puppy. Well, how much did it start with? How much did it end with? So change in kinetic energy is simply kinetic energy final minus kinetic energy initial. So our final was 6 joules right before it landed, minus initials of 0 joules gives us 6 joule change, which makes sense. It's got max energy at the, or kinetic energy at the bottom, nothing at the top, so it's just simply subtract the 2. And what about work? Well, if we actually know sort of how work is defined as kinetic energy, work is defined as the change in kinetic energy, which we just solved for was 6 joules. So not even much there to do, not too bad. Okay. Now, I'm gonna scoot this up a little bit. Knowing how much work it took, the 6 joules, wants to know how far the puppy fell if you knew the force of gravity was 30 newtons. Well, we know that work is also defined as force times displacement, and we're looking in this case for displacement. So we do a little algebra, divide by force on both sides, you get displacement equals work over force, which equals 6 joules over a force of 30 newtons, which gives us 0.2 meters is how far it fell from. So not that far. So thankfully the puppy's going to be okay. Knowing how far it fell, 0.2 meters, what was the potential energy before the drop? So at the very top, what was the potential energy? Well, in this case, we're going to use the gravitational potential energy, which we know GPE is defined as mass times acceleration due to gravity times the height of the object. The mass of the puppy is still 3 kilograms. Didn't lose any mass, so no legs fell off or anything like that. We're going to assume 10 for G, just to keep it simple. And our height, well, we just said was 0.2 meters. So if we plug in all that, 3 times 10 times 0.2, we should get back to our 6 joules. Now, does that make sense to you? It should, considering all the kinetic energy that was gained had to start somewhere, started its potential at the very top. So it started its potential, as it fell, sort of switched out, and at the very bottom became all kinetic energy. So that was before it dropped, and at the very end, right before it's landing, well, we use the same equation. Gravitational potential energy is mgh, mass times gravity times height, or acceleration due to gravity. Our mass didn't change. Acceleration due to gravity hasn't gone anywhere. But our height, right before it lands, it's at 0, or close enough to 0. So anything times anything is 0. Gives us a final energy potential of 0 joules, which again makes sense because all of it turned into kinetic energy for the puppy falling.